Hey Valley Middle, welcome back to another math lesson. Today we're going to explore the world of prime factorization. Before we do that, let's get started with something fun. Our trivia question for the day is, what does the 57 stand for on this ketchup bottle? You see these in just about every restaurant. I know you've picked one up and used one too. So what does 57 stand for? We'll get back to that at the end of the lesson. Let's get to our target, which officially today is 4.1b. I can express a whole number as a product of prime factors with exponents. Let's do this thing. All right, a little inquiry question to start off with. What number is the product of 2 squared times 3 squared times 5? Stop and pause it and let you think for a minute. All right, well, let's break it down and see if we can figure out what it means. Well, 2 squared is really 2 times 2, and 3 squared is 3 times 3, and then times 5 is just times 5. So we could rewrite that as 4 times 9 times 5. Let's solve that 9 times 5 first. I like solving the big problem first. That's 4 times 5. So we'd have 4 times 45, which equals 180. What I did here with this problem to stimulate your thinking is, this here is written as a product of prime factors with exponents, and this one here is just written with the prime factors for the number 180. So today what we're going to do is take a number like 180 and break it down into prime factors, and then also learn how to write it as the product of prime factors. Let's get started with some vocab to begin with. Math word of the day. First of all, prime number, that's any number that just has two factors, one in itself. Take a look at these. 3, 5, 7, 11, and 13 are first prime factors. A composite number then is any number that has more than two factors, like 4, 6, and 8. But when you make a factor tree, these numbers up here, prime numbers, and there's lots of them, they're only going to have two numbers on it. They're going to have the 1, and then they'll have the number itself. I got a flashing message down here that says it's crucial that you know what a prime number is. If you're not sure when you get down to when you're doing your prime factorization, if you know the number 6 is prime or not, you think it might be, make a factor tree and find out how many factors it has. We worked on that last lesson, so you can do that. All right, a couple of different methods to find the prime factorization. The first method here, notice 24 up on top, you break it down, and they chose a prime number to begin with, so they said 12 times 2, which is 24. Then once you reach the prime number, you can just stop with that, but you have to continue breaking down the other numbers. So then they broke down 12 into 4 times 3. Now they've got two prime numbers, so they've got 4 times 3 times 2. They could break that down even further, the 4 into two prime numbers, 2 times 2. So now they've broken it down into 2 times 2 times 3 times 2. Good. All right. A different way you can do it is to break it down by dividing by a prime number. It's just kind of the opposite here. So you take 24 and divide it by 2, because 2 is a prime number. This is even. So 24 divided by 2, you got 12, and then you divide that by 2, which is 6, and you divide that by 2, and you've got 3, and you can look and see that you've got 2 times 2 times 2 times 3, which the divisors, 2 times 2 times 2 times 3, are the same as what we use to multiply over here. I prefer this method. I think most people do use it. When I start, I don't worry about getting a prime number at all. I just take two factors. I actually try to pick factors that are kind of in the middle because I think it works faster. So here's a couple of mid factors for 24, 6 times 4. That breaks down into 2 times 3, 6 does, and 4 breaks down as 2 times 2. So I was able to quickly break that down into its primes. This is how you express it using exponents. If you take a look at it, you've got 3 2's in each answer. 2 times 2 times 2. There's 3 2's, so you got 2 cubed times 3. So anyway, any number that you want to, you can take and write her down, take and choose a couple of factors of that number, and then start breaking it down. I could have chose 8 and 3 here. I would have gotten the exact same answer as they did with 12 and 2 and 6 and 4. Okay? If you choose the number itself, like 24, you're just going to end up with 24, 1 times 24, and then you're going to have to break 24 down. So you have to choose a set of factors other than 1 in the number. But I think that's self-explanatory. Alrighty, let's move on. Why don't you try expressing 36 as a product of prime factors? Go ahead and try it. Okay, let's see how you did. I chose 6 times 6, because it's the first thing that popped in my head. And those 6's each break down into 2 times 3, so I end up with 2 squared times 3 squared, so, or 2 times 3 times 2 times 3. So this is the prime factorization, we call it. This is the prime factorization when expressed with exponents. Just shorten it up. You did this in 5th grade, now we're bumping it up a level. Alright, let's take a look at another problem. Express 44 as a product of prime factors. Go ahead and go for that and pause it. Alright. Well, I chose 4 times 11. I bet you did too. Then I can break that 4 down into 2 times 2 times 11. I end up with 2 squared times 11. Wait, you're not sure. Is 11 prime? Well, you make a factor tree. 11. Got 1 in 11. 2 doesn't go into it. 3 doesn't go into it. 4 doesn't go into it. 5 doesn't go into it, 6 doesn't go into it, and I can stop right there because no factor will be larger than half of the prime. That was one of our rules from last time. So, yeah, 11 is prime. All right, one last question before the ticket to the show. Now we're going to get a little bit harder here. Express 96 as a product of prime factors and then write it using exponents. Go. All right. Take a look at it. I chose 8 times 12. I broke that 8 down into 4 times 2, and I broke the 12 down into 4 times 3. I got a couple of primes here, but I still got some composite numbers left. So you can see my primes come straight down, but I broke 4 down to 2 times 2. Here's times 2 again, and I broke 4 down into 2 times 2 times 3. That's a lot of 2's. Let's see how many. 1, 2, 3, 4, 5. So it's 2 to the 5th times 3. Once again, these down here, this is the prime factorization. This is our target today, writing that prime factorization using exponents. Isn't this a little bit easier to look at? Otherwise, you're probably going to have to count down here anyway. Of course, if you're going to solve it, I'd rather have this so I can go backwards. 4. Get it? Yeah. Both of them are important. All right, let's do the ticket to the show. Here you go. Yeah, you guessed it, Chester. Write the prime factors for the following numbers using exponents. Go ahead and take a second to jot those 2 numbers down. All right, if you have any problems, go back and look at this slide right here, which will have those different methods. I'll put that up and I'll just pause it so you can take a look. I'm going to scroll down a little bit. Again, I like this method right here on the left-hand side. All right, let's do the just for fun. Question, what does the 57 stand for? Interesting, a lot of people think it stands for the number of, or the number of varieties of tomatoes, etc. But actually, in 1896, Mr. Heinz was inspired by an advertisement he saw for 21 different styles of shoes. And he thought 57 was kind of a magic number, so he came up with that marketing slogan, 57 varieties, even though at the time he had 60 products. He still chose 57. Today, Heinz offers more than 5,700 products, but it's still known for 57 varieties, so that's kind of fun. It used to have a pickle on it too, and actually I didn't know they had pickles. That's another one of the myths out there, is that it's 57 different varieties of pickles. All right, this is right from the Heinz website though, so I'm pretty sure I'm accurate. Thanks for playing tonight. Hope you learned something. Impress your parents next time you're out to eat and pick up the bottle of ketchup. Did you know what the 57 is for? Good night.